Hello, and welcome to day 2 of protein synthesis at home learning. I want to start with this picture here. And what it is a summary of protein synthesis. And as you can see at the top, let's look on the left. If you look on the left here, you know that this is the DNA molecule because it is a double helix. And specific regions of the DNA, for example, in this case, there are 3, are known as genes. And these genes could code for specific proteins. And in order to do that, you take the DNA. In this case, the template strand is on the top. So there's your template strand. With the help of RNA polymerase 3, RNA polymerase 2, you will make a molecule of mRNA. And once again, you know this is mRNA because it is single-stranded. And you see U's. We remember that these 3 base packs are known as codons. And then at the ribosome, you will code for the protein. And the protein, once again, will start as a polypeptide chain. That's what this is, a polypeptide chain. And each of these amino acids will be brought by a specific tRNA molecule. Okay, so once you have the DNA, and once you have the DNA and once you've made the mRNA, now you are going to again code for a protein. But in order to do that, you need to get the amino acids. So what's going to happen is there's actually 4 folding or four kind of, I guess, patterns that you're going to begin to create. The first is called the primary structure of the amino acids, of the protein. And all that is very simply the order of the amino acids. And that is determined by the DNA. So if you look at what we just did, that's exactly what you first produced. This is known as the primary structure. And once again, the primary structure is very simply the order of the amino acids, which you get from the DNA. The secondary folding will happen when the chain, the polypeptide chain, begins to start to kind of organize itself. And it may do it like this, which are known as beta-pleated sheets, or it may form what are known as alpha helices. But either way, those are the polypeptide chain beginning to fold. And what's going to happen is in between these kind of folds, there's going to be hydrogen bonds. So that is your secondary structure. So when you see secondary, you're thinking hydrogen bonds. Then the next level of folding is known as the tertiary, or the third level. Now here things are getting a little bit more specific. Now each amino acid that had either a negative charge or a positive charge, or is hydrophobic, which means it does not like water, or hydrophilic, which means it does, these interactions are going to become slightly more complex. And the fourth is called quaternary, but again, we're not going to do that in this class. We'll just get up to primary, secondary, and tertiary. So if you look here, primary structure is very simply the order of the amino acids. So each of those blue dots is one amino acid. So this is just, in essence, a chain. That's primary. Secondary is where you're going to have your alpha helix or your beta-pleated sheets. I'll put a little B for beta. Here, it is all about hydrogen bonding. By the time you get to what is known as tertiary folding or tertiary protein structure, now you're going to find that, let's say over here, this might be a negatively charged amino acid. This might be a positively charged. So they're kind of attracted to each other. You're going to also find that these proteins these amino acids in the middle are going to be known as hydrophobic. And they are not going to like water, so they're not going to want to be near any cellular solutions. And then the amino acids on the edge of this tertiary structure are going to be what are known as hydrophilic. And these guys do like water, or they are happy to be in a solution of something, whether it's blood or whatever, it doesn't matter. And then finally, quaternary structure, which again we're not going to deal with, is going to be the association of more than one protein chain interacting with each other. So in the case of hemoglobin has 4 polypeptide chains that have all interacted. But the quaternary structure is basically more than one amino acid chain. So that's how the proteins can fold. Now, I've been saying a lot about this polypeptide chain and how it's created, but I never really told you how the amino acids are linked to each other. Well, they're linked with something called a peptide bond. Now, a peptide bond is a very special bond, and it's going to be between the carboxyl group and the amino group. So when we start with the basic amino acid is going to have an amino group over here. It's going to have a central carbon. It's going to have a hydrogen. It's going to have a carboxyl group on that side of that central carbon. And then here's going to be what is known as an R group. So an R group I'll tell you about in a second, but that's how all amino acids are different from each other. It's all about the R group. So now that we know about the R group and we know about the basic amino acid structure, I'll show you some again in a second. Now we got to put two amino acids together. Now this R group has absolutely nothing to do with the bonding of amino acids to each other. That will have how they interact with each other, but not how they're bonded together. Now an amino group, which you're going to come to find out, has an N and two H's, and a carboxyl group has a double bonded oxygen and an OH group. And right now you're saying to yourself, I don't even know what that means, but I'll explain. And when they come together, you just can't make up a bond. You can't just draw a bond because you feel like it. So what you're going to do is you're going to lose a water molecule. And that process is known as dehydration synthesis, where you are building something and you are losing a water. Let me explain. So there is your basic amino acid. So if you look, this time I put the R group on the bottom. It does not matter if the R group is on the bottom or R group is on the top. These two can be flipped and it's no big deal. But the purple box on the left and the gray box on the right, they are always in that order. So your amino group, as you see here, is a nitrogen with two hydrogens. Your carboxyl or carboxylic acid is a carbon with a double bonded oxygen and a OH group. Now, for those of you that don't know basic chemistry, oxygen can bond with two things. So there, double bond, fine. Here, oxygen can bond with two things. There's one bond, and then the other bond is hanging on to that hydrogen. So all my oxygens are great. Hydrogen can only bond to one thing. So this hydrogen is bonded to that oxygen. Great. This hydrogen is bonded to that carbon. This hydrogen to that nitrogen. So there's only one bond hydrogen can make. Nitrogen can make three bonds. 1, 2, 3. And finally, carbon, let's kind of erase all this stuff here. Carbon can make 4 bonds. So if you look here, carbon has 1 bond there, 2 bonds there, 3 and 4. Now over here, let's check out this N carbon and what it's bonded to. There's 1 bond, there's 2, there's the 3rd, and there's the 4th. So as of now, this amino acid, every group or every letter, whether it's the nitrogen, the hydrogen, the carbon, the oxygen, whatever, everybody's maxed out. So if you want to add another amino acid over here, you wanted to add another amino acid, you would say, oh, just simply draw a bond like that. Does not work that way. So again, let's look at the structure. That is our amino acid group. I'm sorry, our amino acid, which again has our amino group, hydrogen, R group, central carbon, and carboxylic acid. Same exact thing. I just wanted to show you 2 different versions of it. So now, if you look at this picture here, you will notice that 4 things are the same. 1, 2, 3, 4. So each of those, check, 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 and check, have the same 4 basic bottom half, I guess, if you will. Now, if you look at this, that's the R group. So an R group can be as simple as a hydrogen and glycine, or it could be crazy like methionine, or if you look at lysine, or if phenylalanine has a ring on it, you can see that the R groups are very, very, very varied. They can be simple or they can be complex. but the rest of the amino acid with the amino group, that hydrogen and the carboxylic acid, are the same. So that is very, very important. And the R groups do not come into play when you are putting amino acids together. So let's take a look. We have 2 amino acids, and over here you'll see that all of these bonds, nitrogen is filled and carbon is filled. So how the heck are you going to do that? Well, that's going to be a good question. So you're going to do something called dehydration synthesis. Now what's going to happen is you're going to take that OH group and that H, and together, if you look close, is that H2O, otherwise known as water. So if you can take that H2O out, let's say you can get rid of it, you now have a bond free and a bond free where they can join together. That's what dehydration synthesis means. You're removing the water to create a bond to put 2 amino acids together. So let's look. There, you can see that you're losing the water, which is going to free up a bond right there and free up a bond right there. And look at that. You just made yourself a peptide bond and you released the water. So the general rule is, however many amino acids you have, there'll always be one less than that in water. So let's look. We have 2 amino acids. 1 less than 2 is 1, and that's our water. If I put 10 amino acids together, then I would have 9 waters. Does that make sense? And for every water, you will have a peptide bond. So, same deal. We have 1 amino acid, and we have our second amino acid. When we put them together, we have 2 amino acids, so we're going to have 1 less than that in waters. There's our water that went goodbye. That's our dehydration, and our synthesis is making that thing, which is a peptide bond. Now, they sometimes may call this the amino terminus or the N terminus. And they may call this the carboxyl or the C terminus, whatever. Now, in my drawing here, I took phenylalanine and I took glycine. Once again, I can't put them together, but I can if I get rid of that H2O. And there we go. There's my peptide bond that I just made, and there's my water that I just got rid of. So, our second video is a quick one. It is the structure of an amino acid. It is why amino acids are different, and very importantly, how we can put 2 amino acids together to form a peptide bond. And the answer is dehydration synthesis. So that concludes video 2, and I will see you next time.